Hi, Cecilia.
Hi.
I might sound
Hi.
I might sound different because I have a bad head cold.
I know, so do I.
Yeah, oh man. Tried to play golf today. I was just miserable. I had to blow my nose every 10 seconds. So,
That's not fair when you're trying to play golf.
nah, I know. I was an idiot to even go out and try. Okay, let's see. Pick up where we left off with quads.
Yep.
It's question 6. We're referring to a rectangle in which the length of each diagonal is 12. And one of the angles formed by the diagonal and a side measures 30 degrees. It could be that one, or it could be this one up here. But the way I have drawn it, it would be this one lower left.
hmm
Okay. What's the area of the triangle?
Well, I mean, we only have um
I'm
I
sorry,
feel
what's
like
the
I want
area?
to
What's the area of the rectangle? Yeah.
yeah, I mean, I want to say that you have to calculate all the triangles.
Actually, if we're
Or
just
you
going
have
to calculate the area of the rectangle, the only thing we need is width, or let's call that length,
and with
and width. And so if we take one of these triangles here, we know that's 30, and that's 12, using,
it's a 30/90, it's a 30/60/90.
right. So what are the dimensions of the other two sides?
Um one second, I'm just gonna turn it around.
Okay, I don't blame you. I have to do that sometimes.
Well, I'm used to seeing it like X is on the opposite side of the 30.
Okay,
So X would be 6.
okay.
And then that the side under the 30 would be 6 square root 3.
Okay. So the area of the rectangle is,
12. No, 36 square root 3. Sorry.
which is D. Okay. And the perimeter of the rectangle is what?
Mm,
So this is 6. This is 6 root 3. This is 6, and this is 6 root 3.
I mean, I would say that it's C. So 12 plus 12 square root 3.
Right. Okay.
That wasn't too bad.
No. How many sides does a polygon have if the measure of each interior angle is 8 times the measure of each exterior angle? Now, you understand interior angles and exterior angles?
Well, the anterior angles is the one that's inside of it.
Okay, so this would be the interior angle.
Yeah, and the one on the other side is the,
So this would be supplementary to it.
yeah.
So we'll call that exterior.
hmm
So they're saying that this angle is 8 times this angle.
hmm Yes.
Okay.
I mean, there's 540. Can you use that?
No, because we don't really know how many sides this thing has yet.
Exactly. That's what we need to figure out.
Well, first of all, let's figure out what these angles are. We can figure out these angles because there are linear angles. In other words, x and y have to add to 180.
80.
Excuse me. So if x and y have to add to 180,
well, yeah. You just say
and y is equal to 8x, there's my two equations.
you can't say 180 divided by 8?
No,
Okay.
not at all. Because it says that y is 8 times x.
Yeah, I just figured if you could find the number that you would.
Well, solve these two equations. You need to definitely be able to solve those two equations.
Yeah, well, you already got one that says y is equal to 8x.
Okay?
So you put that into the other one.
Okay, so now we have x plus 8x equals 180. So x is equal to what?
20.
And y is equal to 160. So now let's see if that doesn't help. If that's 20 and that's 160,
Then, I mean, it's supposed to be 540 inside, right?
no, we don't know because we don't know how many-sided a figure it is. If it was a 5-sided figure, it would be 540, but if it was a 6-sided figure, it would be 720. So
Yeah.
let's create the triangles inside the polygon, and then we'll know how many triangles there's going to be. So if this whole thing is 160, what's this angle right here? In other words, if it's 160 from there to there,
It's 80?
okay, so this is 80. What's this angle here?
80.
What's that make this?
20.
Now we can figure out how many sides there are to this polygon. If we take a polygon and break it up into triangles, how many of these 20 angles are going to fit around here? If you know what I'm saying. In other words,
Well, in a circle there is 360 degrees.
okay, so how many of those triangles are we going to get?
8.
No, there's 20. How many times does 20 go into 360?
Oh, sorry. I was thinking 160.
So 360 divided by 20 is 18. So there's 18 of these triangles, so how many sides does the polygon have?
18.
Correct. That was a bit of a tough one.
Yeah, it was kind of weird figuring out.
Yeah. Okay.
So the length of the you have to draw a square and a rectangle.
Okay. There's the square. Area equals 45. And here is the rectangle. And we know that, let's call this x, the side of the square. So what's the length of the rectangle?
5x.
It's 5 more. So it's
5 plus x.
x plus 5. And what's the width of the rectangle, or the small dimension?
It's x minus 5.
Okay. So what's the best next thing to do? Once we get
what x is.
Okay. What is x?
Well, I want to say it's 22 and a half. But that's not right because that's divided by 2.
Well, what do we know? We know x squared equals 45, right? Because the area of this square is one side squared.
Yeah, but 45 is not like, you can't take it's not like a whole number.
Perfect square. No, it isn't. But it doesn't mean we can't deal with it. So now what? What's x? How do I solve this equation?
Well, you want to take the square root of 45.
Okay, so that's what x is. Can we simplify that?
Yeah, I've never really, I know you can do that, but I've never really understood how.
Okay,
I mean,
good.
I've seen it done, but I've never really understood how.
Let's
to
go
do
over
it.
that process. Whenever you're
Yeah.
simplifying a number that's inside of a radical, what you're looking for is factors of 45 where one of them is a perfect square. In other words, that's equal to the square root of 9 times the square root of 5, right?
Mm-hmm.
And 9 is a perfect square, so that's equal to 3 root 5. And that's how you do it. So let's just go do another one. Tell me what the square root of 200 is. Simplified.
The square root of 100 times the square root of 2.
Which is?
50.
What's the square root of 100?
No, sorry, 10. 10.
Okay. So that's how you do that. Let's just do one more. I'll give you a tough one. What's that?
That's 40 times 2. Square root
But 40 is not a perfect square. In other words, that wouldn't advance the situation very much. In order to simplify radicals, we want to take out perfect squares out of that. What's one number that is a perfect square that's a factor of 80? Let's do it the way most people would do it, like that. Because 4 is a perfect square.
Oh, I'm thinking about big numbers because I was thinking, well, 4
Well,
times 20 is 80, but...
Well, that's okay. We'll get to that. But what I'm trying to show you here is that you don't have to find the biggest factor. I mean, you don't have to find a factor that represents the biggest square. You will always continue to be able to whittle it down, even if you don't find the biggest factor. The biggest factor that's a factor of 80 is 16. But we'll still get to the same answer because square root of 4 now becomes 2 root 20, but root 20 is 2 times root 4 times root 5, so we can take another 2 out of there, and we end up with 4 root 5, which is the correct answer. But notice that had we noticed that 16 was a factor, then we get 16 times root 5, and we get there more directly.
So basically you took 2 out of the square root 4, and then you multiplied it with the other 2 you had.
Right, right. But what I'm trying to say is that you don't need to search for the highest perfect square factor. In this case, that was 16. But by finding 4, we were still able to do the problem. It just took a couple extra steps.
Okay, so the square root of 45.
Okay. And in this particular problem, we don't even need to simplify it, but I wanted to go through that anyway. So let's go ahead and simplify it. What is that? Square root of what times square root of what?
5 and 9.
Okay. I put this
And
one in
then,
front because I'm going to change it to a number.
so it's 3 square root 5.
Okay. So what is this side? They want the area of the rectangle. So what is the length of the rectangle?
Well, how can you, I want to say 8 square root 5.
No, because
But
you'd be
can't
adding
put 8
apples to
together.
oranges. If you have an
Exactly,
apple,
that's what I mean.
if you have an apple and an orange and you add them together, you end up with one apple and one orange. You don't end up with two of anything.
No, that's what I mean. So that's why that doesn't
So,
make sense.
so this length, x, is 3 root 5 plus 5.
Plus 5, yeah.
And this width is 3 root 5
That's
minus
minus
5.
5.
So what's the area of that rectangle going to be?
It's going to be 6.
Hold on. Let's lay it out. What's the length? It's the length times the width, right?
Yeah. Oh, so it's not.
No,
So it's
lay it out from scratch. 3 root 5 plus
okay,
5
5 plus 5
times,
times 3 root 5 plus 5.
minus 5.
Oh, you already right plus. I took the other. Yeah.
Okay. Now, notice that we can multiply this together just like we multiplied two binomials together before. Have you heard of FOIL? Do they teach FOIL in Denmark? Probably not, because it's a bad.
I mean, they might, but it's from the inner to the outer thing, right?
Yeah, what you really need to remember is that when you're multiplying polynomials, you just multiply every term by every term. And that'll handle trinomials as well as binomials. The problem with FOIL is it only works with binomials, which we have here, but the way to do it is to multiply that by that, to multiply that by that, to multiply that by that, and to multiply that by that. In other words, every term by every other term.
Yeah. Well,
Now,
they teach us that too. I mean, I've seen that before, obviously. They just call it something else.
okay. And notice something else is going to happen that's nice here. Because we have a plus b times a minus b, that's difference of squares factored. So we know that's going to end up being a squared minus b squared. So we can do this multiplication a little faster by using that knowledge.
Well, that would be, but when you say 3 square root 5 times 3 square root 5.
Multiply both of them. Multiply the 3 by the 3 and the square root of 5 by the square root of 5.
Then 3 of 3, that's 9, and square root 5 and square root 5 is square root 25.
Which is 5. So that's the first term. Minus, what's b squared? If b is 5.
25.
Okay. So now we have 45 minus 25. That's the area. And you see why we didn't really need to simplify the square root of 45. I mean, that was a step we took that wasn't particularly necessary, because what we would have had was this. Square root of 45 plus 5, square root of 45 minus 5. You do this multiplication, you still get 45 minus 25.
Why, if you say 45 times 45, and then the square root of it, that would give 45. Yeah, okay, sorry, I got it. Yep.
Okay, so a couple of lessons here. First of all, this is extremely important on this test. Difference of
Yeah, but those
squares.
3 I know.
You come across it numerous times. So you want to know it not only going in this direction, but you want to recognize it going in the other direction also. In other words, if you have a problem like that, you can solve this multiplication instantly by knowing that's a squared minus b squared.
Mm-hmm.
Okay.
Yeah, those I've got down.
Okay, good.
There's 3 of them, and so.
Right. It was a plus b squared, a minus b squared, and then a squared minus b squared. Okay, we have a couple questions regarding this figure here. What is the perimeter of the quadrilateral? Notice there's 2 quadrilaterals. There's the outside one, and there's also this inside one. But they're referring to A, B, C, D.
Really?
Uh-huh.
Oh, you're reading the first one. No, because it says, what's the perimeter of M and
Oh,
C?
excuse me. Excuse me. You're absolutely right. I was reading up here. They want this right here. Okay.
Well, you have 6 and 8.
Okay.
I want to look at side at 10.
Okay, you'd be correct, because that's a 3, 4, 5 triangle.
5 triangle. And then if all those are 10, it's 10 by 10. But that's not an answer.
Well, that's because they want the perimeter of it.
Oh, sorry. Then it's 40.
Right. And then the next one is what's the area of it?
The area is 100.
Not so quick. It's only 100 if these are right angles. Right?
Yeah.
Okay. So, whoops, hold on. We don't know that those are right angles. In fact, they probably are not right angles. So how are we going to figure out? I realize this is a fill-in-the-blank question, which we had said we're going to skip, but I think it's important that you be able to figure out the area of this thing. Let's draw a midpoint.
You can figure out the area of the big one, and then...
What's the area of one of these triangles? That I've created 2 triangles here. What is this dimension of the dotted line?
Do you mean on the side or on the...
This triangle here. The triangle I put a check mark in. What's the area of that triangle? First of all, what is its base? What's this dimension here? Okay. And what is its height?
6.
So what is its area?
48.
What's the area of the quadrilateral?
96.
Correct. So that's exactly how you do it.
Could you have, like, not done that? Because when you just say 6 times 16, you get 96.
That works also, and it's because...
I'm just thinking, like, you take the half of that to get the triangle, but then you say times 2 to figure out
the principle you're applying is the fact that if you take a rectangle and you put a triangle inside that rectangle, it's automatically half the area, no matter where it goes. In other words, each of these triangles are half the area of that rectangle, including this one. So we know that if we look at this triangle right there, that triangle, that it's going to be half of that rectangle. Well, we can tell that that rectangle is 6 times 16. So that triangle is going to be half, 48, which is the way you did it.
Yeah, but I was saying I didn't need to do that step because, you know, I multiplied by 2 to figure out the area.
Right, because you know that this triangle represents half of this upper rectangle.
Mm-hmm.
Okay. Let's see, I can go to another page here. This is 384. So how are classes going?
You know, first day of school is always interesting.
Yeah. Are you taking any math courses this year or this semester?
I'm not, no, because they don't fit my music schedule, so
Okay. Is that
so
what?
I have to take a computer science class instead.
Ah, okay. What is your major again?
It's music and business.
Okay. The
So I
business.
wanted to take a math class, but it's never fitted my schedule.
Mm-hmm.
So I ended up taking computer science, which is
Okay.
not exactly what I wanted to do, but
Mm-hmm.
because I mean I took math in high school, you know,
Mm-hmm.
like pretty advanced, so I don't understand where it all went, but it did.
Well, trust me, you'd forget it. I know when I became a tutor, I basically had to go back and relearn all the math that I had gotten a degree in, just
Yeah.
because it had been too many years. But I
Yeah.
spent the last 5 years reviewing it, and now I know it better than I did when I went to mines. So,
That's funny,
yeah.
you know. And I also feel like this math that I'm doing right now is actually even easier than the math that I did in high school, you know.
Probably is. You
So,
probably took pre-calculus, maybe even calculus.
yeah, ours, I have no idea what that's equivalent to in Denmark because when I took
Pre-calculus tends to be trigonometry, along with some more
yep,
advanced algebra. And
yep,
then
yep, that's what we did.
calculus is where you get into limits and differentials and integration and stuff like that.
Yeah. It was really funny because I had a person ask me if I knew how to do algebra, but I
Mm-hmm.
had no idea what algebra like what that word meant. So I
Ah.
was like, I don't know, and I was like, you should show me, and I was like, oh, well, yeah, I know that. It's called something, you know. It's just like a language thing.
Oh, you don't use the word algebra. That is funny. Yeah. Yeah.
Nope, we don't. We have a
Okay.
word for it ourselves.
Uh-huh. Okay. All right. How about this geometry problem here? The sum of the
What is
measures of all of the marked angles. So that one, 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 that
Uh-huh.
one. Okay. Any idea where we want to start?
Well, there's 5 angles.
Okay. What are they, and what can we say
They
about
would be equal to 540,
them? Okay.
right?
Yeah.
But we have to find the exterior angles.
Right. So let's examine just one of these corners. Let me draw one of those corners. If this was a regular polygon where they were all equal,
Mm-hmm.
what's the sum of those? 540. There's 5 of them, so each one would be 108.
108.
540 divided by 5.
Mm-hmm.
Okay. So if that one's 108, this one's 108,
Yep.
and this one is the same as this one, so this would be 72 because it's supplementary with this one. So this one would be 72.
52.
So they would average 144. They would total 144. How many of those pairs do I have?
Well, you have 5, so you have 720.
That's the answer. Now, the fact that I made the assumption that this was regular, even though clearly it's not, you know what regular means? It means equal angles.
But it doesn't say that it's drawn to scale, so it easily could be regular.
Well, it doesn't matter, is my point. In other words, if I make this 100 instead of 108, then one of the others has to be 116 or has to make up for it. Because we know the sum of all of them have to add to 540.
Yeah.
So the sum of all the exterior angles have to add to 720, regular or not. And
so really, we didn't even need to calculate it if we knew that.
I'm sorry, what?
So if you know that all the exterior angles are supposed to be 720.
No, 540.
No, in exterior angles.
Oh. Well, these aren't, I mean, these are kind of exterior angles, but they're not really. That's an exterior angle. That's an exterior angle, but both of them aren't really, unless you extend both lines like they've done. So I don't right offhand know that the sum of the exterior angles would be, given the sum of the interior angles is 540, I could not tell you what the sum of the exterior angles is, other than now I know that it has to be 360 if we took just the sum of the exteriors, but there's actually two with each vertex, and that's how we got 720. The only way I knew how to figure this out was to do the analysis that assumed you were dealing with a regular pentagon, and then know that even non-regular pentagons would have the same sum of the interior angles and sum of the exterior angles. So it shouldn't matter if I base my analysis on the fact that it's regular. Okay. Okay, we have a four-sided figure. We'll just draw any four-sided figure here. W, X, Y, Z. The measure of angle Z is 10 more than twice the average of the measures of the other three angles.
C is equal to W plus X plus Y divided by 3 times 2 plus 10.
Okay.
Right?
Right. Again, I'm going to use the exact same method that I did in the last one. I'm going to assume, since they're giving us information based on the average of the other three angles, I'm going to say the other three angles are the same. Even though they're not, the fact is they're talking about the average, so I'm going to add these three and divide by 3. And now Z is 10 more than twice, so Z must be 2x plus 10, right? Now what?
Well, you also need don't you need an equation for how you get X?
Well, what can I say about all four angles?
You mean all four angles? Oh, that they're all 360?
They add to 360.
360.
So I've got 5x plus 10, that's the sum of all four angles, equals 360. Now I can solve for x.
Why do you have 5x? Where does that get from?
Because there's 1x, 2x, 3x, 4, 5x.
Oh.
In other words, I'm adding x plus x plus x plus 2x plus 10. There's the sum of the four angles.
But then when you, so when you solve it, oh, you just solve for x.
Right. And they want angle Z, which we know to be 2x plus 10. So x is 70, if I solve that equation. So this angle right here has to be 150. So Z is equal to 2 times 70 plus 10.
Yeah.
And let's just go backwards here, just to make you comfortable that we didn't cheat by assuming the other three angles were equal. If Z is 150, what's the sum of the other three angles?
210.
Exactly. And notice that it doesn't matter if x is equal to x is equal to x. This could be 60, 70, 80. The fact is that they compared angle Z with their average, so their average has to be 70. It doesn't matter if they're all 70 or it's 60, 70, 80. I can base my analysis on the fact that they're equal. Okay. Okay. M and N are the midpoints. We have a square.
Yeah.
We want the perimeter of the shaded region.
Yeah.
Which means we're going to need this measurement here, and we're going to need that measurement there.
Yeah.
And we know that's 2. So what is this diagonal equal to?
It's 2 square root 2.
Now let's examine this point from, what is MB equal to?
MB is 1.
What is ND equal to?
1.
And what is this diagonal here, the hypotenuse of this upper left triangle, equal to? This is 1, and that's 1. What's this other slanted? Okay, now we have everything we need for the perimeter. What's the perimeter?
It's 2 plus
I have a square root of 2, and I add 2 square roots of 2. How many do I have?
3 square root 2.
Uh-huh. So there's your answer.
Yep.
Number B. Okay, number 15. Let me just open the next page and see what they're... I think they want the area of this. What is the area of the shaded region?
What the area is?
Uh-huh.
Well, wouldn't you have to get the area of the square and then...
That's usually, any question that asks about shaded region is almost always a subtraction problem.
Yeah, you find the area of the square and then you subtract.
So it's the area of the square minus what?
Minus the area of the
large triangle minus the area of the small triangle. Okay, what's the area of the square?
4.
What's the area of the large triangle? This one here.
2.
Yep, we know that instantly without doing any math, because triangles always are half of the rectangle. And what's the area of this one here, the small triangle?
1.
What's the area of a triangle? Is 1/2 base times height. So what's the area?
A half.
It's a half. So what's 4 minus 2 minus a half?
1.5.
Uh-huh. And that's answer A. Okay. Sure. Page that it's clear. We don't get to do but one question on it. Okay. Let's go to circles. We have finished lines and angles, triangles, and quads.
So we only have like 15 minutes left. Do you want to do some data sufficiency, or do you?
Yeah, let's do that. Good idea. Excuse me.
Oh, no worries.
Okay. We left off on data sufficiencies at 19. We did that. We did 20. Let's look at, hold on here. Let's see. Do we have any data sufficiencies coming up? Yeah, we got 3 in a row that are not data sufficiencies, but let's make sure we do them all.
Yeah, that would be nice, because I need to get in the habit of getting something different, you know?
Right, right, I agree. There's no downside to doing this.
Okay, if a circle whose radius is x has an area of 4 square units. I don't know what square units are, but
this is asking about a very important concept that we need to talk about it if you're not familiar with it. What is the linear ratio of these two circles?
I mean, it's 3
to 1.
3 to 1.
What is the area ratio of those two circles? It's 9 to 1. You take, when you have a linear ratio and you're going to area, you square it. So if you start out with a 3 to 1 ratio, the area ratio is going to be 9 to 1, 3 squared to 1 squared. If I had a sphere, 3-dimensional, that had 3x as its radius, the volume of this sphere would be 3 cubed, or 27. So the volume ratio is 27 to 1. So when you go from 1 dimension, where we have a radius, to 2 dimensions, where we want the area relationship, we square it.
Would the area be 36?
I'm sorry, what?
Would the area be 36?
No, it's going. Oh, yes. Excuse me, because all we know is the area is going to be 9 times bigger than this area. Since they told us that this area was 4, then we know it's 36.
36.
Okay. This same principle applies to all figures, even squares, rectangles. If I have two similar squares, this side is 2 and this side is 5. What is their area ratio? What's their linear ratio, first of all?
Um, 3 to
5 to 2.
5 to 2.
They're both squares. Okay? So what's their area ratio? If their linear ratio is 5 to 2, square that, top and bottom, and you get their area ratio.
Square top and bottom?
Uh-huh.
Well, then it's 25 to 4.
And that's exactly right. If they gave you a square that had a side of 2 and this one had a side of 5 and they said what's the ratio of their areas, it's 25 to 4.
Mm-hmm.
Same thing if I had similar rectangles, same thing if I had similar polygons. No matter how many sides, if I give you a similar one and I say that this side is 2 and this side is 4, they have a linear ratio of 2 to 1, but they have an area ratio of 4 to 1. This area is going to be 4 times this area. So it doesn't matter whether you're circles or any other figure. Same with triangles. Okay, so that's an important concept. When you go from 1 dimension to 2 dimensions, you square it. When you go to 3 dimensions, you cube it. All right. They love these questions about executives. I guess they figure if you're taking the GMAT, you're going to plan on being an executive one day.
Okay. Well, you would have to multiply some of these numbers.
Okay.
Okay, well, the 5 executives who earn $150,000, they earn $750,000 each, or together. And then the 3 executives that earn 170, they earn 510. And then 1 earns 180.
And we're going to add those 3 numbers because questions about averages are always questions about totals. You always are going to want to total stuff up. That's the first key.
So
the moment you see an average.
1 million. So the total is 1,440,000.
What's that? And then what's the average?
160,000.
Good. In other words, you knew that 9 times 16 was 144, right?
Mm-hmm.
Good. That's a good thing to know because that saves a lot of math. So the answer is B. 23.
Oh, the next one's a solid fun.
The next one is a tough one. But not as tough as it looks. Clearly, the square root of a squared plus b squared is not a plus b, right? So we know that much? Okay. So it's not x over 6 plus x over 5. So we have to do this problem a different way. What's our first step need to be?
Well, I really want to eliminate
How would you add these 2 fractions? If I said, what's x squared over 36 plus x squared over 25 equal to?
Well, you would find a common denominator.
There you go. That's the secret. What's the common denominator going to be?
Between 36 and 25?
36 times 25.
900.
Okay. What's up top? What's this term on the left going to be?
X.
No. In other words, when you're doing this math,
oh, it's going to be 25.
There you go. 25x squared.
Plus 36. That's what you meant. Sorry.
Right. Okay, now we're getting somewhere, because now we can add the numerators. What do we get?
61.
What is the... So how do I simplify that?
You take the square root.
Well, we know that the square root of a over b is equal to the square root of a over the square root of b, right?
Mm-hmm.
Okay, so let's use that principle. So we've got the square root of 61x squared all over the square root of 900, which is 30.
Mm-hmm.
Which answer is this?
Well, it can either be A or C.
No. In other words, let's simplify this. What can we do to this numerator to simplify it?
Well, if you take the square root of x squared, don't you just end up with x?
Yes. What's left over? Square root of 61.
30.
There's our answer. Notice that it doesn't quite agree with that. Actually, when you take...
That has like the lines next to it. So
right, that's absolute value, and that's because when you take the square root of x squared, the answer is actually plus or minus x, which is the same as absolute value of x.
Yeah, but I guess it didn't matter here because we didn't have to actually find the number.
Well, they didn't give us another answer that's exactly the same as this without the vertical bars. So we knew this was correct because that's what we got. Okay, so the key here is sometimes you have to add those fractions to make progress. Those two fractions. Adding them together is the only way we were able to move forward on that.
Yeah.
Okay, here's a data sufficiency, finally.
If 14 sculptures at a craft fair are also painters, how many painters are at the fair?
Are you familiar with the word Venn diagram?
No.
Okay. Well, let's talk about, you've probably been shown this picture. You may just not be familiar with it. It's called Venn diagrams. We use a Venn diagram whenever we have
Oh, you want me to answer that?
No, I'm just trying to figure out how to. We have painters and we have sculptors. And we have some people who are both.
You have 14.
We don't really have any that are none, so I don't need the outside box. Which is the easier one to analyze, 1 or 2?
2.
Okay. So 2 tells me that 7 of the sculptors are not painters. So I know that there's exactly 7 that covers this area right here. Okay. So I know that's 7. Well, there's 14. There's 14 sculptors at the craft fair, so how many must be in this part right there?
No, doesn't it say that there are 14 sculptures on top of the 7? Because I say if 14 if 14 sculptures
Are
have there,
also
also
painters. You're right.
so it's
14 goes
14.
there. 14
Okay.
goes there. Yes, you're correct. Okay, so taking into account statement number 2 only, along with the stem, gives us this picture, but it doesn't tell us how many painters there might be.
So you can't use it.
Well, it doesn't answer. So 2 is a big no. Now let's look at 1. The number of painters and the number of sculptors adds up to 44.
Well, then you don't know the 7 part. So you just know that there's a total of 44, but you don't know how many sculptures are not painters.
Right. In other words, I'm looking at this picture with statement number 1, and as all I know is that this part here plus this part here plus 14 adds up to 44. But that's not going to tell me how many painters I have.
You can't solve it.
Not with number 1. So now, can I solve it with both?
Yes.
Right. Because the number of painters and the number of sculptors, there's 21 sculptors, there's got to be 23 painters, 14 painters or sculptors, so this has to be 9. No, it's number of painters and the number of sculptors adds up to 44. I didn't do that right. 21 and 44, this would have to be 23. Now, and when I put numbers here, I'm not including the overlapping part. In other words, there's 23 pure painters, there's 7 pure sculptors, and there are 14 people who do both.
But the answer is C.
Right. So we were able to figure it out with all 3 pieces.
Okay.
All right, we got time for another one here. Let's do 25. Excuse me. What method? You know, a good idea that I suggest to all GMAT takers is the very first time you see a question, ask yourself the following question. What method am I going to use to solve this? Am I going to do it algebraically? Am I going to do it back solving? Am I going to do it picking numbers?
Well, yeah, but there's a formula to this.
We can do it algebraically. Just because there's a formula to it doesn't mean we can't back solve it.
But it doesn't say
back solving, it's going to, we'll go through both methods, but let's try back solving it. I'd like to see you back solve from start.
Okay, well, if he has 4,000 left.
Well, we're going to pick 4,000. How much money did he invest? So 4,000 was invested at 5%. Now, let's see if everything makes sense. How much was invested? I want you to work through the logic.
Okay, so you need to find out. So if 4,000 was invested at 5%. I'm just going to write the numbers down.
Well, let's put the other piece of information that tells us. If 4,000 was invested at 5%, how much was it?
200.
Okay, that's plus $200 in interest. Okay, how much was invested?
And then he would have invested 6,000 at 6%. which would give him 360. So that's the answer.
Right. So back solving was really quick.
Yeah.
Okay, let me show you the algebraic way. Real quick. We let X be the amount invested at 5%. Then the amount invested at 6% is 10,000 minus X. Okay? Well, we know that 0.05 times X plus 0.06 times 10,000 minus X has to equal $560. There's the algebraic way to solve it. Notice that that still has quite a bit of work to do to solve it. In other words, you have to distribute this 0.06, and then you have to solve this linear equation.
Yeah, it was way easier too.
Back solving was way easier. Now,
yeah, well, what kind of gave it the clue is that there is a formula for it, but it would have to say whether it's
well, we used that formula. We just kind of did it intuitively. What happens when you back solve is you use the proper algebra. You just don't necessarily know how to set it up algebraically, if you know what I'm saying.
Well, we learned, like in the book, those two formulas, you know, for compound interest and simple interest, but it doesn't even talk about what kind of interest it is. So
right. Yeah. The key really, well, now notice that this also, if 4,000 would have been wrong, we would have known absolutely whether we needed to go up or down, right? And that's a key for back solving. If you're going to know whether you have to use a higher number or a lower number, then back solving is almost always the correct way to go. I've never seen a problem where back solving wasn't correct. I mean, some problems you're not really going to know whether you need a bigger number or a smaller number. And then back solving may take 3 tries instead of 2. But as long as you're going to know whether to go up or down, the most you'll ever have to try is 2.
Well, great.
Okay.
So we got to number 25.
We got to number 25, and we got through quads. So we can pick up from there next time.
Yeah. Thank you so much.
You're welcome. Have a good evening, and I'll talk to you next time.
Talk to you next time.
Okay.
Bye.
Bye-bye.